Hello again, everybody. We are here graphing some more lines. Actually, in this one, the lines are already graphed for us. And what we're going to do is we're going to find the slope of these lines, right? It asks us to find the slope of the lines below. So that is exactly what we are going to do. So if we look at these, right, they're already here. They're already graphed for us, okay? And we need to find that m value, right? That m value. We don't need to find the whole equation, okay? So we can kind of forget about that b value here. It's just asking us for the slope, okay? And so what is the slope? Again, the slope is where it is moving, how much it is moving, right? And so we're thinking of, for slope, we're thinking rise over run, right? So that's what we need to determine. We need to determine how much is this line moving up or down and right as it goes from point to point, okay? Again, when you do problems like this, you read a line like you read a book. You read it from left to right. So no matter what the line looks like, start from the left, okay? Whether that's the lowest it is or the highest that it is, start from the left and then go to the right. Okay, that'll help you to do it right each time. Okay. The other thing that often happens with these problems is that it's difficult to count the slope at first because the points aren't highlighted for us, okay? And we don't know exactly how much it's going each time. So that's a helpful thing to do first is highlight where the exact points are, okay? And you might be saying, oh, it's a line and there's points all over it, right? And that would be true, but what we want are those whole number points where it would go through, like right through a corner. We want to highlight those spots on the graph where it is going exactly through a corner of the grid, okay? So I'm going to highlight that here for the first one, okay? So again, where does it highlight, where does it go through a corner? I would say right here, it's going through a corner, okay? Keep scanning right here, and then right here again. And right as you draw it, right, it should be a consistent amount that it moves each time, right? You want it to be, the points to be the same amount apart, right? That would mean it's a consistent slope. And that would be good because that's what we want, right? Because the line moves consistently the same amount each time between the points. And so again, we're determining the rise, which is how many spots is moving up or down, and then how many spots is it moving to the right. So again, read it from left to right, just like a book, and start with the leftmost point that you highlighted, okay? So that's this one for me. So I start there, and then I move, I'm counting to the right here, but again, I'm figuring out, because it's a fraction, I want to figure out how many spots is it moving up or down as it goes from this point to the next point that you have highlighted, okay? So this one goes up one, right? That's all it goes, right? And I know it goes to the right too, but just for my rise, from this point to this point, it just moves up one space. So my rise would be one, right? But then it moves to the right, one, two, three, right? Do you guys see that? And so if it's moving up one, that's positive one, and then right three, that's positive three, that would be my slope. My slope or my m value would be 1/3 for this one, okay? And that's it. Okay, so once you highlight that or find that, you are done with this type of problem. Great. Let's move on to number two. Again, same thing, find the slope of this, okay? So again, and on this one too, it doesn't give us highlighted points. So let's do that first so it can be easy for us to count, okay? So it goes through a corner right here. I keep scanning, goes through another corner right there. So we have these points drawn, okay? And I just, like, there's another one in here, but I just want to show you what it would be like if you skipped one and you counted the slope this way, and that you would still get it right. You just have to, it's just a situation that you run into sometimes. So again, we're counting here rise and run, and we're thinking, okay, starting from the leftmost point. Again, I know for this one we started with the bottom point, and you might be thinking, oh, why don't we start at the bottom down here? But here, we again, starting from the leftmost point. I know this is a pretty steep line, but yeah, this is the point furthest on the left. So we start here, and we're thinking, okay, from this point to this point, it's moving down a certain amount, because you worry about the up or down first. And so I'd say it's moving down 1, 2, 3. So down 3, so that means a -3 for my rise number, my top number of the fraction. And then it moves right 1. Okay, so down 3, right 1. So down 3 and right 1 means -3 over +1 would be the slope for this one. And I just want to show you one more thing. Like, if you counted from here to here, right? Say you skipped one, or maybe you even missed this one too. And what you would count, right, from this point to this point, it goes down 1, 2, 3, 4, 5, 6. Down 6 and right 2. Okay, so say you got a slope of -6/2. You might recognize that this is a fraction that can reduce. Okay, so reducing fractions is something you would have done in middle school. But what's the giveaway? The giveaway is that both the top and bottom numbers are even, and that's a dead giveaway that this is a fraction that can reduce, right? So reducing fractions means dividing the top and bottom number by the same thing. And so if you divide them both by 2, you get -3/1, which is my actual slope. So that's what will happen if you miss a point in there. You can still get it right. It just requires you to reduce the fraction. So that's why it's that I know that's annoying to deal with. So that's why it's important that you be very particular when you draw your points that you get all of them so that you know exactly what the slope is going to be. Okay, let me erase these, put a few more examples up. Okay, we got 3 and 4 up here. Let's look at these. So again, same thing. When the points are not, sometimes they are. Sometimes the points are highlighted on there for you, which is awesome. That's helpful. But a lot of the time it's not. So that's what I want to show you guys, just when the points are not highlighted for you. So you have to deal with that. Okay. Let me actually zoom you in here on number 3, and you can tell that this one's going to be a little bit trickier. So sorry, it might be a little wobbly here, but we look at number 3, and for this one, it is tricky because you see like a lot of these points. Let me see if I can do this without being shaky. Like there's a point right there you can see. That one right there looks so close, right? That's so close to hitting the corner of a grid, but it doesn't. Same with that right there. You see that's really close to hitting the corner, but it doesn't. We have to be very particular with finding the exact points. Okay, so like for this one, I said this is a clear point. It gets close, but doesn't hit an exact corner till right here. Okay, and again, that's why it's important to draw more than one, because some of you might be saying, oh, if I just draw 2 points, that's all I need to do to count. Okay, but to make sure you get it right, it's really helpful to highlight as many points as you can. Okay, so again, same thing. I draw, it looks like it's close, but doesn't hit a corner until right here. And then you compare, you say, okay, are these two about the same space away from each other as these two? And that's your way to check, because sometimes they're not. You might be saying, oh, so I must have miscounted somewhere. I drew a point in the wrong spot. So good way to check yourself. Okay, let's count what our slope would be. Okay, so down, right? Because I start with the leftmost point. So I count down. How many am I moving down? 1, 2, 3. So down 3 means -3. And in your slope, your fraction here, that's the top number, so -3. And then right, 1, 2, 3, 4. So 4, -3/4. So each of these points, I should move down 3, right 4. So let's count. Down 1, 2, 3, right 1, 2, 3, 4. Good. Down 3, right 4. So -3/4 works, okay, and that is the slope for that one. Let's do this guy here, okay? Slope for this one. Got a point right here. Got a point right here. I keep going, okay? Again, I'm just going every place I see it cross through a corner, I'm drawing a point. And again, my drawings are a little bit imperfect, so if you zoom in, you might see it. It doesn't quite go through a corner, but yeah, it's fun. So yeah, so let's count these, okay? So these points are closer together. Every time I start with the leftmost point, so I move up 1, and right 2. So up 1 and right 2 means +1/2 slope, or +1/2. Okay, there it is. Now I want to show you one other thing when we deal with slopes, and then we'll do one or two examples where we're actually finding the whole equation, which actually isn't that much harder. Okay, finding the slope's the hard part. So if you get that, if you understand how to do that, then you'll be in good shape for the next part. But one more thing. A difference between these two lines, okay? Obviously, one of the slopes are different, okay? The slopes are different values, and that's obviously a big difference. But something else that I want you to notice is that this, again, if you read this from left to right, just like a book, this is declining, right? It's if you were like on a skateboard on the leftmost part of the point, you would be rolling down, picking up speed, and it'd be hard to stop. It'd be like one of those videos that you see with people wiping out on the skateboard. But if you, right, were on a skateboard on this one going, let me draw the little dude. There he is. on a little skateboard. You would not be able to go that way without kicking a little bit and pushing because that is an incline that's going uphill. I don't know if that helps that explanation, but do you see the difference in the directions here? This one's going down, declining. This one's going up and inclining. Now I want to tell you about why that happens. The negative, okay, negative slope versus this is a positive slope, okay. All negative slopes are going to decline like this. Are going to from left to right. They're going to be going down, okay, down and right. Whereas positive slopes, all positive slopes are going to be going up or increasing from left to right, okay. That's something I want you to notice as well. We'll talk more about that later on, but there it is. Okay, two more examples, like I said. So here are my new lines, and notice the directions change. It no longer says find the slopes of the lines below, it says find the equations, okay? So the whole equation, it's not just the m value. Now we're finding m and b, because both of those values are necessary for a complete slope-intercept equation, right? And that's just a little bit more. That's just a little bit more information, right? Because the slope, like I said, is the big one, but the b value is just a little bit extra that we have to find, okay? But that's not too hard to find, okay? So I need to, if I'm going to do this, find the equation of a line below, I need to find the m value and the b value, and then I put it together in my equation, okay? So let's do that for number 5. So it starts out the same way as it would have before. I need to first highlight some points that it goes through, okay? If I look at this, okay, here's a corner. I look up, there's another one. Okay, so it looks as though this one has a nice and easy slope because every single time it goes up and over, it crosses through another corner. So that's good, okay? So think about what that means for your slope. If it's, again, starting from the left, and then going up and right, it's moving up one and right one, up one and right one, up one and right one. Okay, so up one and right one means positive 1 over 1, and that's the same as just normal 1, right? Anything over 1, we can write as just 1. So either one of those is fine. But my slope is 1, or 1 over 1, okay? So putting that in my equation here, what did I just find? I found my m number, the number that's going to be multiplied by the x, right? So in my equation, right now, I know y equals mx, right? The letters y and x stay there, but I know the m number now. So it's not mx plus b, it's 1x or 1 over 1x. Either one of these is fine. But I know the m number now for this line. It's 1. Now all that's left is to find this b value, okay? And what does that mean again? Well, the b value is the y-intercept, right? Where does it touch the y-axis? And I'm able to see that pretty clearly with these, okay? So I just scan along my y-axis, and it touches right there, right? And so you look at that and you say, okay, what value is that? Where is it touching the y-axis? And it is touching right there at -2. Okay, that's the value from the middle, 0, -1, -2. That's where it touches, okay? And so I don't need to make that a fraction either. That's fine to just be a whole number. So 1x, and then the b value, because it's negative, I put -2. And that's the equation of this line, y equals 1x minus 2. That's it, okay? Find the equation of this guy. Again, for that, I'm going to need my m value and my b value. And again, I need to highlight some points that it goes through. So that would be right here. I scan along, right, not any other ones until right here. So I start with my point that is on the left, okay? And I count down 1, right? So it goes down 1 or -1. And it goes right 1, 2, 3, 4. So down 1 and right 4 is how much it is moving from this point to this point. So as a slope, again, that would be -1 over +4 would be my rise over run. And then my b number, again, that is the y-intercept, or where does it touch the y-axis? And that happens up here, right? That it touches this y-axis right up here, okay? And so if I count up, 1, 2, 3, 4, 5, 6, 7, 8, 8, right? So that touches the y-axis at +8, okay? +8. So that is the b value for this equation. And then you put it together, okay? So it's always going to be y equals the m number times x, so -1/4 times x, and then plus the b number, so +8. And that is it. That is my equation, okay? Very nice, very nice. Hopefully that makes sense to you. We'll talk a little bit more about slope here in another video. So good job. Go Pens.